So let's look into the law which relates the magnetic field, the current, and the force on the wire. So before we begin, we need to understand a terminology that is mutually perpendicular. So let me show you an example. See, these three rods are mutually perpendicular. Why? 90-degree between the red and the green, 90-degree between the green and the white. No, not that. Not that. Yes, 90-degree between the red and the white. So all the three are making an angle of, or at an angle of 90-degree with respect to each other. Okay, that's why it's called as mutually perpendicular to each other. Understood? So these three rods are mutually perpendicular to each other. Again, if you look at it carefully, see 90-degree, 90-degree between those two, and 90-degree between these two. Make sense? Right? So they make an angle of 90-degree with each other. So it's called as mutually between themselves. They are perpendicular to each other. Okay, so I've drawn a diagram. You have your thumb, your index finger, and your middle finger. Right? It's coming towards us. That's why it looks a bit weird. This is up, and this is kind of right. Okay, so you guys have to try to hold it in that way. Again, this is coming towards us. Right? Take out your left hand and do that. Right? Hold it in front of you. Are you guys doing it? You have to do it because it's part of your syllabus. Right? Part of your understanding. More than syllabus, it's part of your understanding. So what is the law tell? Well, kind of simple. Stretch your thumb, forefinger, and the middle finger of your left hand such that they are mutually perpendicular. That we understood. What is it about? And again, you can hold your, turn your hand so that when you look at your index and the middle finger, they make an angle of 90-degree. When you look at your thumb and your index finger, they make an angle of 90-degree. And again, when you look at your middle finger and your thumb, they make an angle of 90-degree. Okay, so try looking at them like how I showed in this 3D view. Same thing over here. So once you have done that, the next thing is, if the first finger points in the direction of the magnetic field and the second finger in the direction of the current, then the thumb will point in the direction of the motion or the force acting on the conductor. So what they're trying to tell is, so just a second. So I remember this as father, mother, child. So first finger points in the direction of the, actually this does not make sense, first finger. Anyways, the index finger points in the direction of the magnetic field. The middle finger points in the direction of the current. Then the thumb will point in the direction of the force. Okay, so again you can remember it by father, mother, child, in that order. Father, thumb, mother is index, and child is the current. So I'll explain what is exactly is happening. I'll explain that. So let's apply this to the video which we watched, right? The experiment which we did. So here in the first case, right? Again, hold out your left hand in this way. So first is orient your middle finger in the direction of the current. That is from left to right. Hold your index finger up, right, in this way. Again, look at the diagram. So how is the thumb pointing? The thumb is pointing towards you, is it not? So that's how the copper wire will move. Okay, that's it. That's what it tells. That's what the Fleming's left hand rule tells. It relates if you give the direction of the current and the magnetic field, it will tell in which direction the copper wire will move. As simple as that. Right? So in case 2, same thing. The direction of the current is not changing. Now you have to turn your hand a bit. Okay. So you have your index finger pointing downward now. Sorry, middle. No. Index finger, yes. The current is from left to right itself. The index finger is pointing down. Right. Now the thumb is pointing, yes, away from you guys. And that's how the copper wire will move. It's not. So again, if you guys are curious if this is what happened over there, you guys can watch the video again. Right? I hope you guys enjoyed it, because I though enjoyed this part. So this is basically how a motor works. This is the basic funda of how a motor works. That's why I like it. Okay, so let me read the statement again. I think I didn't do a good job. Stretch the thumb, forefinger, and the middle finger of your left hand such that they are mutually perpendicular. Right. The first finger. Okay, this is. Let me cancel this. Let me write this as what is this? Magnetic field. Na? So your index finger or forefinger. The forefinger points in the direction of the magnetic field. The second finger, that is your middle finger. Okay, finger is, we need finger. Forefinger points in the direction of the magnetic field. Middle finger in the direction of the current. Then thumb will point in the direction of the motion or the force acting on the conductor. That's all the law tells. Quite simple, is it not? It's very visual. It's just in your hand itself. Everything is in your hand. And the easy way to remember is this is your father and your mother who points you guys in the right direction, and this is you guys. Right? So father, mother, and the child. Okay, so now pause and write this down.